So we're going to talk briefly about the principles of magnification and triangulation. With a scope and any other optic equipment, you're going to have some amount of magnification depending on how close or how far away that you are from an object. Now this plays a role when you're attempting to measure objects. Again, we know that the tip of the probe to the bend of the probe is a distance of 4 millimeters, but that could look vastly different trying to measure the length of the K from here versus from here. So you have to make sure that when you're measuring objects, you realize that you're having a certain amount of magnification, and you want to make sure your instruments and the object you're measuring are on the same plane. So now a little bit about triangulation. So as you read, triangulation is this principle that you have your ability to control your scope and your field of view from one direction and then your instruments from another direction, with the goal being that your working space will then become an apex of a triangle from two different locations. Now, when you're attempting to triangulate, you want to start with a wide field of view, insert your instrument until you find it, and bring it into the center of your field of view, and then you move together to where you're going to be working. And then you can continue to move to other locations or other working spaces, keeping the center of your probe or your working instrument in the center of your field of view. The goal of this lab is that it will train you that even without necessarily coming back to a wide field of view, you would be able to develop the muscle memory, even in a narrow field of view, to retriangulate to where your working space is. If we were to look in the box, you can see that my instrument and my scope are not completely collinear or parallel, but they come at an angle to one another, again, my working space then being the apex of the triangle. Again, the lab will give you more practice with this.